Hi, everyone. This is Rob Gray from ASU and the Perception and Action podcast, back with another article review. Today, I want to look at the topic of learning by analogy. And this is something I covered way back in episode 16 for the first time. And again, I talked a little bit about some more recent research in episode 146. For those that don't know, learning by analogy is the idea that we can teach movement skills by instead of giving very explicit instructions about how to move your body, we can convey the movement pattern we're hoping the athlete will achieve through some metaphorical or analogy for the biomechanics. And the classic example that's been used in a lot of research is if you want to teach someone how to do the movement of a basketball free throw, instead of telling them what to do with their elbow and snap their wrist, you tell them, imagine you're reaching up on the shelf and getting a cookie out of a cookie jar, which is why I have the picture there. And there's multiple other ones we can use. Nick Winkelman in his great book, The Language of Coaching, shows you how to develop these and gives lots of great examples. Holding a golf club and to get the right pressure, imagine squeezing a tube of toothpaste, and so on. So this is a really, it's been interesting and it kind of shown to be somewhat controversially, but shown to be an effective tool for coaching. So, what I want to look at today is a recent paper that kind of dived into this in more detail, published in the Psychology of Sport and Exercise. And to foreshadow, this is really doing something that I've kind of been pushing for, not only in terms of analogy research, but focus of attention research. That is moving into some of the nitty gritty details of it, moving beyond the simple contrast between internal, external, analogy, explicit. Let's get into some of the details and figure out why things work and why they don't. And this paper is really an attempt to do that. So the authors note that, the idea of analogy, as I mentioned, is to use a biomechanical metaphor. And the hope is that one of the things it's hoped to achieve is I can take lots of information, right, about what I want your body to do and put it into a simple instruction that's likely to be less cognitively demanding, right? Research has shown that analogy, in particular the work of Rich Masters, has shown that analogy instruction seems to work. After acquisition, learners learning by analogy seem to have the similar performance levels as those learning through explicit instruction. But where the real advantage comes in, and this is what Rich has shown, is that analogy seems to reduce the incidence of choking, right? So when you learn by analogy, you don't have the opportunity for what Rich Masters calls reinvestment, going back to those explicit instructions about what your elbow and your wrist should be doing. So it reduces the chance that you're going to choke under pressure. And he has some research showing that evidence for that effect. But there's also some people that have questioned this research and with valid concerns about it. The effects are kind of, I talked about, are not super strong sometimes. But also there's this kind of confound that Bob and Ricky has raised, other people have raised as well, that a lot of the studies contrasting explicit instruction and analogy have not really done a good job of equating the load of the instruction. And the example is, for example, in the studies Masters has done on basketball, for shooting a free throw, you get that one instruction about the cookie jar. Well, in the explicit condition, the person gets eight or 10 things they have to remember. So the working memory and cognitive loads and attentional demands are not really equated. And indeed, Bob Nicky and colleagues have shown that when you do match those things, you get 4 analogy instructions and 4 explicit rules, you get similar effects. Okay. There's also the case that we really haven't dug into anything about what exactly needs to be in the analogy. We just kind of use the same ones, or people, what needs to be there? How many things should we mention? So this paper is trying to address some of these issues, right? So the goal of this present study, what they're going to do is look at 2 different types of analogies. So they're doing this, as I said, getting into the nitty gritty. What needs to be in a good analogy? And they're going to compare that to explicit instruction. And I'll show you the examples in a second. So the 2 types of analogy instruction are rule-based, what they call rule-based biomedical metaphor. What that means essentially in their study is, it means what they're going to do is give you a separate analogy for each part of the movement, right? So they give an analogy of what you should be doing with your elbow, analogy of what you should be doing with your knees, right? So that's going to be a combination of things. The second type of analogy they're going to call IIM, information integrated biomechanical metaphor. That's like my cookie jar example. That's why where you try to get the whole movement described in one analogy instead of doing it all separately. And the other really big innovation of this paper is they're going to start looking at joint coordination, right? As we said, I've emphasized a million times on the podcast, coordinating degrees of freedom is what skill is all about. We haven't really looked at, there's some studies have looked at variability of movement and how that's affected by using analogy versus instruction, but no one's really got into the coordination issues. So that's what they want to achieve. And they basically had four hypotheses they want to test, right? The first one comes when you compare the rule-based metaphors versus explicit instruction. Remember, rule-based metaphors, we're going to give you a separate analogy for your elbow movement, your wrist movement, and so on. They're using dart throwing in the study, by the way. So if there's something inherently better about analogies as compared to explicit instructions, when I give you four analogies, you should be better than when I give you four explicit instructions. So the rule base should be better than the explicit instruction. The second hypothesis is if there's something special about the integrated one, where I try to convey the whole movement in one instruction. Another one of the example of this is some work that Keith Davids has done on tennis. Swing like you're moving like a rainbow, right? So that's another example of an integrated one where you're conveying lots of biomechanical things in one instruction. And if there's something special about that, then that should be even better than the rule-based use of a metaphor. So it's not just the use of analogy itself, it's combining them. And then they have some predictions about related to the coordination. They predicted they would find kind of freezing effects in degrees of freedom. And they also expected to see changes, right? If these analogies are changing your performance, you should see it in your joint coordination. So those are the basic things they're predicting. As I mentioned, they used a dart throwing task. Before the study began, they had a pre-study where they brought in 5 experts they used to generate the instructions, right? And I have them shown here. So the explicit instructions had, so in the explicit group, there were separate groups. You got 3 rules you had to follow while practicing. Throw the dart by slowly extending the arm, release the dart softly, release the dart diagonally upward direction. So we're giving you explicit prescriptive instruction about how to throw the dart. Compare that with the rule-based metaphor. So this is a type of analogy. So for that, these 3 things, those are 3 instructions were replaced by 3 metaphors. So for example, slowly extending your arm was placed by moving the arm as if you were bowing in a greeting. Release diagonally upward was imagine sliding your arm along the slope of a hill, right? So we're just having the same number of instructions, things we're saying to the participant. In one case, they're explicitly referring to the body movement. In another case, they're a metaphor. And then the third condition was this integrated one. And the instruction there was throw the dart as if you're throwing a crumpled up piece of paper into a waste paper basket located slightly farther away from the dartboard. Right. So we're trying to convey all of those, extending your arms, being soft because it's paper, moving upward because you have to go beyond the dartboard. We're conveying all those things in one instruction, one to the person, one analogy. Right. So those are the 3 groups that were compared. They took 45 novices and split them into these 3 groups so that it's a between subjects design. You're throwing from the same distance. In pre and post tests, which were 12 trials each, you were trying to hit the bullseye with every throw. In the acquisition, the training, there was 144 trials. Again, you were trying to hit the bullseye. In the pre and post, obviously, you weren't getting the instructions. They were just, or the analogies. Those are just in the acquisition. And finally, they had a transfer test where after the training, instead of aiming at the bullseye, you had to try to hit different zones on the dartboard. For example, triple 15. So things that were lower and higher with the transfer test, right? So that was the basic design. To do the analysis of coordination, they took the joint angles of the wrist, elbow, and shoulder. They calculated the covariance, essentially the variance. They did principal components analysis. I'm not going to go into too depth because they didn't find a ton with that actually. And then they looked at absolute and variable errors of your shots as performance measures. So absolute error, how far away were you from the bullseye or in the transfer condition, the area where we were learning. Variable, how consistent were you, right? What was the spread around where you hit, right? So those are the basic things. What was found? Well, in terms of performance, right, there weren't enormous effects, right? So there was no difference at all in acquisition, right? So if you look at the blocks, if you look at the absolute errors and variable errors, there was no significant group differences at all. Everyone learned at the same rate. There was a significant effect of block. Obviously, everyone got lower errors as they practiced more. What they did find was the only main really performance effects they found is when they did pairwise comparisons between the pre-test scores, and the post-test retention and transfer for each group. So what they found were the absolute errors got significantly smaller after training and significantly better in the transfer condition for the integrated metaphor group. So the one that was given that whole metaphor about the crumpled paper. Neither of the other groups showed significant changes. The variable error was sort of the same. They showed the integrated group showed that the transfer was significantly better, but so did the explicit instruction. So the results are a little bit messy and not really clear in terms of performance. Overall, they're suggestive that the integrated metaphor analogy is the best. Okay, but there's certainly not slam dunk like everything is that way. The joint coordination kind of supporting the performance effects. The only significant changes in the joint coordination pattern were in the integrated condition. And this, if you see watching me, you can see the graph is showing the coefficient of variation across time. The dashed line is the pretest, and you can see there was changes in the integrated group. None of the other groups had significant changes in the way they were coordinating their movements. So this is kind of supporting of the performance research. So overall, the authors concluded that there seems to be evidence suggesting that this integrated metaphors is better. So it's not just an effect of having the number of instructions. It's not just an effect of reducing cognitive load. It seems like there's something special about combining this all into one metaphor. Okay, it both results in some of these performance changes and in changes in joint kinematics. What are my kind of assessments of the paper? I had a few things I picked out. One, in part of the description of the methods, they described that their transfer test of hitting different parts on the board was also a pressure manipulation. So they said the setting was prepared to purposely trigger psychological pressure because they're throwing to different target positions. No, that's not a pressure manipulation in my book. That's a transfer. You can't have both, right? A transfer is you're just doing something new. Yes, it's gonna make it harder, but that's not the type of pressure we talk about when we talk about performance pressure. So I wouldn't consider that a pressure manipulation at all myself. The other things that I would kind of like to see, a pure control group would have helped to interpret the results, I think. Also, I think it would be good, I hate when people try to put too much on you in one study. So I would say, future research to look at those joint coordination changes and assess how functional they are, right? Something like an uncoordinated, uncontrolled manifold analysis to see, is the changes we're seeing actually keeping you more on task? Are you better performance, right? Right now, we saw those integrated ones were better in the changes occurred only in the integrated group, but we don't know if they were beneficial at all. We don't know what they were doing. But overall, I really like this study because I think it's moving this field in the direction we need to go, right? We need to get into the nitty-gritty of instructional research. We need to stop doing the broad brush comparisons of internal versus external, analogy versus explicit. We've done a million of those in every possible task people can think of. It's time to start understanding, what about those instructions? What are they doing exactly? How can we change them, right? So I really commend the authors for going in that direction. So that's it for today's article. Thanks for listening. If you wanted to support the podcast, you can go to patreon.com/perception action, where you'll find links to getting written transcripts. And we do a monthly Zoom meeting where we talk about issues related to skill acquisition with all the people in the group. So thanks for joining me. Cheers for now, and keep them coupled.